So here we have a last type of linear differential equation. We are going to see now the differential equation with a variable coefficient. Remember, one of the two most important methods that we have, we have that case 8 and case 9. Case 8, that variation of parameter, and case 9, equation reducible to a constant coefficient. So this case 8 and case 9 both are the most important. On case 8, one 5-mark question is always there. On case 9 is also there is a 5-mark question always there. So mainly that 10 marks weightage you will have on case 8 and case 9 only. Yes, case 8 is a completely different where we use case 8 mainly for the functions like sec x, cosec x, tan x, cot x, or function of e raised to x. That about the case 8 previous one, where that variation of parameter method we use to get a yp particular integral, and that based on the integration formulas of and based on that Wronskian W also. Okay, so that we already learned in the last session. Now come to the last method here, that equation reducible to constant coefficient. Okay, once we reduce the equation in constant coefficient, we have to use method 1 to 6 then. Generally it is on the method 1 to 6 there after that. So the type of the differential equation is like this. Here you will observe one of the differential equation with a variable coefficient. See why this is a derivative, its coefficient is a variable. You will observe that ax plus b is there. So this is the differential equation with a variable coefficient that we have, and our aim is to reduce it to the constant coefficient like we already see in the previous examples. So for that purpose only, we are going to replace ax plus b by e raised to z. Okay, ax plus b equal to e raised to z, and then automatically values of this derivative will get like this. Let I show you the derivation. Actually, this derivation is not required. This derivation is not required. But as we are going to replace this ax plus b by e raised to z, if you take log on both sides, we get log of ax plus b. Log of ax plus b is equal to z. Is that? Now tell me the value of derivative. What's the derivative of LHS?
a by x plus.
Very good. First of all, it is 1 upon ax plus b into the derivative of x. So a upon ax plus b. That's correct. Very good. Is equal to, now we are differentiating this with respect to x. So RHS will become dz by dx. Dz by dx only. Okay. Uh, now, actually, our aim is to get the value for one more thing is there that this we are replacing ax plus b is equal to e raised to z. We take a log on both sides. Log of ax plus b is equal to z. Okay. Now our aim is to get the value of ax plus b into dy by dx. Okay. So yes, we'll come to that here. Can we write this dz by dx as dz by dy into dy by dx? Can we write like this? Dz by dx is written as
Yes,
dz.
sir.
Okay, okay, so we can write that. So what happens then? Now we can take this ax plus b on the right hand side. So we'll get ax plus b dy by dx is equal to a times that is a dy by dz. Is that dy by dz? So I will rewrite like that. I am taking this term on that side. So I will take a dy by dz. Which term I taken on this term I taken on this side. This a dy by dz is equal to that ax plus b into dy by dx. Is that? Is it?
Yes, sir.
Okay. So and we got this value of ax plus b into dy by dx. This is that same term is equal to a dy by dz. Now you will observe the RHS is with a variable coefficient. The this differential coefficient have variable coefficient, and the left hand side have the differential coefficient as a constant coefficient. So we replace it is as a dy. a dy. Now this capital D operator only changes. In original equation, original differential equation, capital D is operator as a d by dx. Okay, but now we are saying here is again d, so that d is not the same. Actually, it is a d, that d is a d by dz. This is a d by dz. Or some authors are using here a d dash y. They are using d dash notation everywhere, and they say d dash is a d by dz. This one that I am written here. This is a d by dz. D by dz is a d dash or d only. So no need to increase the notations. Just you should know what is the exact d that you have. So whenever we use substitution, ax plus b is equal to e raised to z, we say ax plus b into dy by dx is a dy, where that capital D is a d by dz. That later on will come to know while writing the yc and yp. Okay. So where you should focus. Now similarly, you can derive the other formulas also. The derivation is not required. I will tell you where you should focus. You should focus when the differential equation occur like this. For this variable coefficient, we have to do a substitution. First thing, the most important thing, we replace ax plus b equal to e raised to z. Then we directly write these values. We are not going to prove it. Ax plus b into dy by dx. This term we are going to replace by here only. Okay, then we have other term, say this a2 ax plus b bracket square into d2y by dx square, that we are going to replace this actually here. Okay, that we are going to replace directly by here, this value, and we get a differential equation of constant coefficient, and then we are going to solve by our regular method, so which are the important things that the formulas you should remember? Ax plus b into dy by dx is a dy. Ax plus b bracket square into d2y by dx square is a square into d minus 1y. A square into d minus 1y. So these are the formulas that you have to remember. This form actually known as a Legender's form. Whatever the first differential equation you have, this form is known as Legender's form. Legender's form. Now, this second equation that you are observing here, this is actually a particular case of a Legender's form where ax plus b is nothing but it is only x. So indirectly, a is a 1 and b is a 0. When a is a 1 and b is a 0, the Legender forms is converted to the Cauchy's form. This is a Cauchy's form. So both are same. Actually, you just remember the Legender form. You can automatically get Cauchy's form also, because we have to do the same thing, because ax plus b is nothing but only x is there. So we replace that x equal to e raised to z. When x is e raised to z, then x dy by dx is equal to dy, where capital D is a d by dz now. But capital D is that d by dz there. X square d2y by dx square is a d into d minus 1y. X cube d cube y by dx cube is d into d minus 1 into d minus 2y, and so on there. Okay, so the important thing is this substitution. This substitution should click to you, and then you can easily solve these problems there. So there are two different forms in variable coefficient. One of the form known as a Legender's form, and the other form is known as a Cauchy's form. No need to by heart the names of the form also. Just you should know whenever the variable coefficient occur, that variable coefficient we have to use for a substitution. So if ax plus b is a coefficient, put x plus b equal to e raised to z only. And when x is only the coefficient, put x equal to e raised to z only. So this is only a standard substitution. Don't use any other substitution, because this substitution only works and that converts the differential equation to a constant coefficient there. If any doubt, yes, you can ask. If you have any doubt here. So can we move to the numerical then?
Yes, sir.
Okay, good. So question number 1, solve x square d2y by dx square. I'm reading this, those who are not able to read it. See, x square d2y by dx square minus x dy by dx plus 4y is equal to cos of log x plus x times sine of log x. That is a differential equation we have. Okay, so here is a differential equation. Yes, anyone? What should be a substitution first? Yes. What should be the
X
substitute?
equals to a raised to z.
Yes, x equal to, na? Yeah, correct. X equal to e raised to z. Actually, this is a Cauchy's form. So we should say x is e raised to z. So this is the very important thing that you should know. So whenever x is e raised to z, what is the value of z?
Log x.
Yes, z is a log x. So these two things we require to simplify the differential equation. Therefore, the differential equation becomes. Now what we are going to do it? We are going to replace x dy by dx by, yes, anyone? What is the value of x dy by dx?
dy.
Dy, correct. So I'm writing from last terms here. So I will write here minus dy. I'm written for that. This plus 4y will be as it is. Now here x square d2y by dx square should be replaced by d into
D minus 1y.
d minus 1 of y, correct. And that's one on the now RHS. Cos of, yes, what is this? Cos of, yes,
Yes, sir.
z only now. Remember, we are converting the differential equation from variable x to the variable z. Okay, so cos z plus x sin z. That about the RHS. Now we have to simplify this LHS here so that we get differential equation of a constant coefficient. So I can write it as a d square minus d become a minus 2d, is it? Plus 4 of y is equal to cos z. Is it x is correct here? Whether I am written it correctly? You should not have any of the term in terms of x. So this writing x is wrong. Here you should write e raised to z into sin z. I hope you are getting. This differential equation now in terms of d by dz, that capital D operator is a d by dz. So as it is a d by dz operator, so RHS is a function of z only. There should not be a term of x anywhere. Okay. Now how to solve this? Yes, anyone? This is not new. This is not new now. Do it.
YC.
Yes, YC. So complete. Tell me the YC. Do the calculation and tell me the YC.
Sir, e to the power x
Not correct.
c1 cos root 3x plus c2 sin root 3x.
Not correct. The main mistake what you made here.
E to the power z.
Z, correct, very good. Now the differential equation have the independent variable as z. We get an answer in terms of z, and at the end we are replacing that z by log x, and then we get that answer. Okay, so I'll show you.
It's because only, sir, here d is equal to d by dz, right?
Yes, capital D is a d by dz now. Correct. So I will
Okay,
show you
okay.
here the first part. When we started x equal to e raised to z here, x equal to e raised to z, this is the replacement, and that about the differential equation. Okay, this is the differential equation that you are getting. We already seen that. And here is yc. You'll observe yc you should write in terms of a z. So e raised to z, c1 cos of root 3z plus c2 sin of root 3z, because roots are 1 plus or minus I root 3. Now calculate yp here for cos z plus e raised to z sin z. Calculate yp. Which cases we should use? Yes, which cases for yp?
Two cases will be used, sir.
Which one?
So first one will be cos z will in which we
By
will replace,
trigonometry.
yes, sir, d square by minus 1.
A square. Very good. And second?
Second, sir, we will replace, first of all, we will replace d by d plus 1.
Very good. So that is the
Because
case number 5. Yes,
and then
correct.
apply the trigonometric
Very
sine
good.
function.
Very good. Yes, you are correct now. So you can do that calculation. Do it. When you do the questions on differential equation with variable coefficient, automatically you will have the revision for constant coefficient, because every time you replace that you use substitution which converts the differential equation to a constant coefficient, and then you have to think for a method. You have to think for method number 1 to 6, or case 1 to 6, I will say. Yes, anyone completed? Yes, anyone who finished this? What about the YP?
Sir, YP is coming minus 2 by 5 sine Z plus 3 by 5 cos Z plus sine Z by 2.
Oh, very good, Ankur. Okay, let me see. Your YP is my YPs are completely different, Ankur, probably. Okay, so let we see here whether you made any mistake, or here is any I done some mistake here. So you will observe the formula for YP is 1 upon phi d of, now instead of fx we say fz. Okay, so 1 upon phi d is a d square minus 2d plus 4 cos z plus e raised to z sin z, that about the f of z. We are separating. We are finding yp1 for cos z and yp2 for e raised to z sin z. So for cos z, yes, simple thing that we have to do it. We have to replace d square by minus 1. So we replace d square by minus 1 here. But on this side, we replace d by d plus 1. We replace d by d plus 1 and we take e raised to z outside the operator. E raised to z comes outside the operator. Now, the case which occurs on the left hand side is a linear term in the denominator. We come across 3 minus 2d. Whenever linear term comes in the denominator, we have to rationalize. So numerator and denominator is multiplied by 3 plus 2d. So numerator becomes 3 plus 2d, but denominator becomes 9 minus 4d square. 9 minus 4d square of a cos z. That's one. But on the right hand side now, when you open these brackets, it becomes d square plus 2d plus 1 minus 2d minus 2 plus 4. So few terms gets cancelled and we left d square plus 2 only. Is it d square? No, d square plus 3 we left. D square plus 3. You will observe here is this d square term. This d square term. Then you have here plus 1 minus 2 plus 4. So 5 minus 2 is a 3. So d square plus 3 is there. So d square is replaced by minus a square. So minus 1. So this case is very simple. Second yp2 is a very simple. You got here as a 1 by 2 e raised to z sin z. On this side now, we again replace d square by minus 1. So 9 plus 4 is 13. So it becomes 1 by 13 here. And 3 plus 2d, it is a 3 times cos z plus 2 times derivative of cos z is a minus sin z, and this one is your yp. Okay. I think Ankur, you may make a little mistake. Not an issue. At least you tried. That's a good sign.
Sir, I have just making mistake in the denominator addition, sir. 9 minus 4d square. That I have took minus 5, which will be 13.
13. Okay, okay. So this may happen. So yes, a small mistake you made here only in the number. Okay, good. But is it a final answer when we say y is equal to yc plus yp? So that will be the answer in terms of z, but original differential equation is in terms of x. So we should write the answer in terms of z, not an issue, but don't forget to write where z is a log x. There are two ways of writing the answer. Let I tell you. The first way, yes, you can write the answer like this. Thus, y is equal to, just a minute. Thus, y is equal to yc plus yp, and that is y is equal to yc is e raised to z, e raised to z. Just have to check it. Where is that? Here. C1 cos of root 3z plus C2. Okay, just a minute. Just a minute. Okay, plus C2 sine of, okay, that is not writing on that side now. This is root 3z. That is a yc plus yp now. Yp comes 1 by 13. 3 cos z minus 2 sin z plus e raised to z by 2 sin z. So that about entire solution. You write on this entire part where you should write z equal to log x. So that way you should write the complete answer. Or you can do one more thing. Every z you can write by log x. Every z you can replace by log x, and your answer will come as y is equal to that e raised to z becomes now x only, because e raised to z is x there. So this is x into C1 cos of root 3 log x plus C2 sine of root 3 log x plus 1 by 13 3 times cos of log x minus 2 times sine of log x plus x by 2 sine of log x. So that way you can write the answer. I hope you are getting what I'm saying. So there are two ways of writing the answer. Either write the answer only in terms of z, but don't forget to say where z is a log x, or replace everywhere by z by log x and write the final answer. That's one. Any doubt, anyone? If you understood this one example, you can do any example actually of a variable coefficient, because important part is conversion from variable to the constant coefficient, and the remaining calculations are very, very straightforward there. Okay, so I'll show you the next question then. You can start now. What should be a substitution now?
Two x plus 1 is equal to e raised to z.
Very good, Hanith. Yes. 2x plus 1 is equal to e raised to z. 2x plus 1 is equal to e raised to z. That is the correct one. What is the value of then this term? What is the value of this term? When if we take 2x plus 1 is equal to this one, we are taking now 2x plus 1 is e raised to z. What is the value of then 2x plus 1?
2 dy.
Yes, correct. It is not only now dy, it is a 2 dy. And what is the value of this one? 2x plus 1 2x plus 1 is there. Y, it is not y. So 2x plus 1 bracket square d2y by dx square. This will be this will be 2 square, that is 4 d into d minus 1y. So these values you have to replace on the left hand side here, and you have to convert to the Okay, do that calculation. Replace that and calculate yc. Do the calculation till yc. This is important part. You should know that here this is the substitution, and when ax plus b dy by dx is there, it is a dy, and where ax plus b bracket square d2y by dx square, it is a square into d minus 1. So this is the value of a square. Some students forget to write these values of a square there, and obviously that capital D operator become now d by dz there. So d by dz. Yes, anyone? Oh, what is the yc at least? Yes, anyone?
C1 e raised to 3x plus C2 e raised to minus x.
Again, I think you are saying the answer in x. It should be in terms of
Z, Z.
z. Okay, so don't do these mistakes. Yes, you require little time to to write in terms of z. I know, because once we practice in one notation, you generally have that thing. So first thing, when we replace 2x plus 1 by e raised to z, this 2x plus 1 dy by dx 2 dy, this is 2 square d into d minus 1 y. When we replace it here, the differential equation becomes like this: d square minus 2d minus 3 of y is a 3 by 4 e raised to z minus 1. Actually, I taken that 4 on the right hand side. If someone not take on the right side, that is also okay. Do with that way only, your answer will remain same. Okay, now this is the simplified. We have to calculate yc and yp for this one. So for yc, obviously the roots are, you'll observe, yes, what are the roots? Is it minus 3 and 1? Sorry, 3 and 1, 3 and minus 1.
3 and minus 1.
Yes, 3 and minus 1. So your answer should be C1 e raised to 3z plus C2 e raised to minus z. Okay, that way. So that about yc. Come here. So this is okay. So minus 1 and 3, you'll observe here. Minus 1, 3 are there. So C1 e raised to minus z plus C2 e raised to 3z. That about a yc. Now we have to write a yp there. To get a yp, yes, which methods we require? Replace d by, for first term, what we do it for e raised to z, we replace d by, not getting any answer, huh? As exponential function is there, na? So we should replace d by 1 here. And what about constant minus 1? How to get the yp for minus 1? We replace d by
0.
0, correct. Okay, so that's one. So replace d by 1 and replace d by 0, you get yp1 and yp2. So that yc plus yp1 plus yp2 will be the complete solution, where the value of z is log of 2x plus 1 now. Value of z is log of 2x plus 1. So is there anyone who completed? Okay, so can I show you a solution then? Because no one is telling the answer.
1 by 8 into 1 minus 3 by 2 e raised to z.
Okay, I think it is correct. Let me see. Okay, no, not correct again. Some mistake is there in numbers. Or if you keep that 4 on, so you check whether at the end your answer is same or not. So it is not 1 by 8, it is 16 is coming. So you'll observe it is a 1 upon 5d of that RHS. So 3 by 4 is constant taken out throughout. It is e raised to z, it is e raised to 0 z. Replace d by 1, you get minus 1 by 4 e raised to z. And replace d by 0, you get just minus 1 by 3. So it becomes plus 1 by 3. And that about a yp. So y is equal to yc plus yp, where z is a log of 2x plus 1. Where don't forget to write this here. Okay, so our answer is in terms of z, but that z have the replacement as a log of 2x plus 1, or you can replace that everywhere. Any doubt, anyone? Okay, 1 minute. So I think yes, Asif is saying minus 3 by 16 e raised to z plus 3 by 12. 3 by 12. Yes, correct. My mistake. So this 4 should be multiplied here. Okay, very good. So that's observation. Yes, here we should write that. We should write that. Only this is a missing here. This 4 into 3 is a 12. So 1 by 12 should be there. This is 1 by 12. Okay, that's fine. Okay.
Sir, it's correct. 3 by 4 multiplied by 1 by minus 3
Yes,
will
sir.
be minus 1 by
Yes,
4.
sir, it's
Minus 3
correct.
by 60. Yes, 3 gets cancelled. Oh, sorry, my mistake. So how Asif is how Asif said you 3 by 12. Whatever I written, that's correct actually. Sorry. Good. Okay. So Asif, it is not 3 by 12. 3 gets cancelled and it comes 1 by 4 only. Okay, good. The others are also listening. Yeah, good. Okay. Last question of the same pattern. Just I will show you complete solution then, because I know all you can do it now. So here is question number 3. Or just anyone is interested to do it, or I will show you the complete solution. Yes. Can I show a complete solution, or you are interested to do it right now? Okay, 2 minutes. Yes, Ankur. Okay, take time. Find out this YC. This is third order differential equation. X cube d cube y by dx cube plus 2 into x square d2y by dx square plus 2y is equal to 10 times 1 by x plus x. 10 into 1 by x plus x is there. RHS is 1 upon x plus x. Yes, Ankur, are you completed or anyone? Anyone else?
It will take time, sir.
Okay. Okay. Sorry, I shown the solution here. So see here, we replace this d into d minus 1 into d minus 2 of y. Second become 2 times d into d minus 1 of y. And last is 2y as it is. 10 into 1 upon e raised to z plus e raised to z. Okay. So 1 upon e raised to z can be written as e raised to minus z, and that is e raised to z itself. But on the left hand side, when you multiply and simplify, it comes d square, d cube minus d square plus 2 of y is equal to 10 times e raised to minus z plus e raised to z. Now there are two ways. Either you can solve this original differential equation, or you can convert this bracket into cos hyperbolic z also, because we know the formula e raised to z plus e raised to minus z upon 2. E raised to z plus e raised to minus z upon 2 is a cos hyperbolic z. So either you can solve in terms of cos hyperbolic z, or you can solve it in exponential form. If you want to solve in exponential form, you have to replace d by minus 1 and d by 1 there. And in cos hyperbolic, you have to replace d square by plus a square. That is d square by 1. So both way you will get the same answer, equivalent answers. So step 1 for yc, we take d cube minus d square plus 2 equal to 0, and the roots are coming minus 1 and 1 plus or minus I. Minus 1, 1 plus or minus I. So yc will come here. C1 e raised to minus z plus e raised to z c2 cos z plus c3 sin z. So because of that roots. So yp 1 upon phi d of fz, and here we replace d by say minus 1. When we replace d by minus 1, as minus 1 is a root, it comes a 0, so we multiplied by z. Now it is important thing again, whenever denominator comes 0, don't multiply by x. Now you have to multiply by z and differentiate the denominator, because the independent variable is z now. That's one. And here we replace d by 1 only, and we get yp directly there. So that's where we get the answer. Where don't forget at the end to write z is equal to log x. Z equal to log x. If any doubt is there, yes, you can ask. Is there any doubt? No. Okay. Now let me sum up for this topic. So we started linear differential equation LD. Okay. In LD, that is divided in two parts. This is a differential equation with constant coefficient and differential equation with variable coefficient. So this is the case number 9 actually. This is our case 9, variable coefficient. Just we seen how to handle the differential equation with variable coefficient. Actually, it is a reducible to constant coefficient by a substitution of exponential term there. Now, when we have a constant coefficient, again it is divided into parts, CF and PI. For CF, the main important methods are three. There are many other also. For example, I said repeated once, if root is repeated twice or thrice. If complex root is repeated. So there are the cases like that also, but that generally never occur. So I'm not written here. So if m1 and m2 is root, we write c1 e raised to m1x plus c2 e raised to m2x. If it is repeated, we write c1 plus c2x e raised to m1x. And if alpha plus or minus I beta is a root, we write e raised to alpha x, c1 cos beta x plus c2 sin beta x. So that about the cases for CF here. And in PI, mainly we have these 8 methods. Okay, all these 8 methods. Out of that, the method number 1 to the method number 6, you will have one question of 5 marks. Okay, in exam, you will have case 1 to 6, 5 marks. Then variation of parameter, that method 7, that you will have a 5 marks question. And this one, undetermined coefficient is generally not a question. There is not a single question comes on undetermined coefficient. Mainly the question comes on variable coefficient again for 5 marks. but variable coefficient is depending on case 1 to 6 again, case 1 to 6. Only undetermined coefficient is not asked. The reason is only it is optional method for shortcut methods, case 1 to 6. For case 1 to 6, it is optional method, or it is an alternative method, I will say, alternative method for solving the same numerical. Okay, is it clear? Any doubt, any issue in this topic?